Hey everybody, welcome to another interesting episode of this AI journey, where in every episode we discuss an interesting topic or an interesting algorithm. Likewise, today we are going to go through one of the most popular algorithms in machine learning called as K nearest neighbors, right? This is a supervised algorithm and it's used for both classification as well as regression. So without wasting further time, let's try to delve into the basics or the mechanics of this algorithm. So K nearest neighbors. So as the name implies, it tries to find out the K nearest entities to a particular entity. And based on these nearest entities, it tries to guess the class that this entity belongs to or the value that this entity should possess, right? So let's take one example of each category for both classification and regression. Let's say you have a typical problem that looks like this, like you have, see, a table here where you have two different fruits categorized into two different types, like based on the radius and the weight. Let's say the radius is 10 centimeters and the weight is, say, 50 or maybe say 50 gram. Then the fruit is going to be, say, an apple. I'm just making up numbers, all right? These are not real numbers, but maybe if the radius is, say, 8 centimeters and the weight is, say, 40 grams and the fruit is an orange. Again, if the weight is like, say, 8.5 centimeters and the radius is 8.5 centimeters and well, I think let's say this is a diameter, right? It's for the radius. And if the weight is, say, 45, then again it's an apple, okay? These are just example numbers, not meant to be like factual. But then if we plot this on a graph, right, like so on and so forth, if we try to plot a graph here, say you have the diameter and then the weight. Typically, what you're going to get is, like, say, some fruits, all the apples, in fact, categorized into one clump, and then let's say these are the oranges, okay? I mean, it's not supposed to be black, but then let's say these are the oranges, just in a different color, right? And now I have another row in this table, right? Another row where I have, say, a diameter of some value X and the weight of some value Y. And based on this X and Y, I want to know which category does it fit into. By studying this table, right? By studying the characteristics in this table, I see some fruits over here and some fruits over here. So now given a random fruit, this one, which say lies somewhere over here with diameter value D and then weight value W, which class does this belong to? It belongs to this class of apples or this class of oranges. How do I solve this problem? So this is a typical K nearest neighbors problem. So here what we do is, as the name implies, nearest neighbors. How many K? So let's say K equals 5, all right? So what I try to do is I try to find out the 5 nearest neighbors to this fruit. So let's say, and these nearest neighbors are based on the distance, right? So how do you compute the distance? It's like this is the X, which is the diameter, and this is the Y, which is W. So under root of D square plus W square, right? Using your Euclidean distance, right? That's the distance. So we use this metric. So let's say this distance is D1, and then the distance here with this nearest neighbor is like D2. And then the vertical distance is like, say, W1, and here it's W2, right? So basically, the distance from this person to this person is going to be given by square root of D1 minus D2 bracket square plus W1 minus W2 bracket square, right? That's the distance here. So in this way, using this formula, we compute the distance between this, and then this one. And then based on this distance, we take the nearest one. So this is the one with least distance. This is the second one with the least distance, the third one, the fourth one, and then say the fifth one, right? So these five are the closest to this fruit based on the distance, right? And as we see, out of these five, these three, we have three of them belonging to this class and just two of them belonging to this class. So out of five, a majority of three fruits belong to this class. So we conclude that this fruit has a greater propensity to belong to this class rather than this class, right? That's how we classify this unknown fruit into an orange instead of an apple. Clear? That's how this K nearest neighbor works, right? I hope this is clear. If you have any questions, just type in the chat box below, right? Chat at the bottom of the video. So you can choose different values of k, like k might be equal to 3 or k might be equal to 7. So generally odd numbers are preferred because if you have odd number values, then you can get a majority of one class and minority of the other class, right? Suppose you use 8 or something, and if you get 4 of one class and 4 of the other class, then this creates ambiguity, right? So it's good to use odd number values. And then for regression, how does it work? Let's take an example here. Let's say you have another table like this, where so this is like, say, a house price prediction table, right? So based on the carpet area and the number of floors maybe of the house, right? You have a house price basically. So the carpet area is, say, 1,000 square feet and the number of floors is 2. And the house price is supposed to be like, say, 35 lakhs. The carpet area is, say, 1,200 and number of floors is, say, 1. The house price is supposed to be 40 lakhs, so on and so forth, right? Based on these two parameters, you're deciding what the house price is. That's a typical regression problem, right? So how do you go about this now? Similarly, you plot a graph here. Let's say carpet area and number of floors, right? So let's say you have different points over here, right? So these different points belong to different house prices, right? And then you have been given another point here, this one. It's an alien point. Let's say you have its own value X for the carpet area and own value Y for the number of floors, and it's supposed to find out what is the house price of this by studying this table. So how do you use K nearest neighbors for regression? They use a similar distance formula, the Euclidean distance, as we just did it above. And this time what you do is you find out the K nearest neighbors. Let's say again K equals 5. So the 5 nearest points to this point, let's say it comes out to be this one, this one, this one, this one, and this one, okay? So these are the 5 nearest points to this point. Now what you do is you find out the actual house price of these points from this table, right? And then what you do is you just take an average of these 5 house prices. That average is basically the house price of this unknown point. All right, so unlike classification where we basically try to consider the majority of the points belonging to a particular class, here we are taking the average of all the points from the list of points situated within K equals the particular number, right? So that's how we have used K nearest neighbors for regression. Clear? So I hope this is as easy to understand. If you have any questions, please feel free to pose those questions in the comment box at the bottom of the video. And for more such videos, please feel free to write to me in the comments itself, right? So thank you for watching this video. I hope you like this. Let's keep learning. Let's keep getting enthusiastic about different concepts. And with this enthusiasm, see you in another video soon. Until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.